Imagine the early solar system as a sparse, primitive void. Before the familiar neighborhood of 8 planets existed, there were only 2 massive planetary bodies orbiting the Sun in close proximity. The larger world, Theia, was a giant. It occupied a mass exactly twice the size of modern-day Earth. This diagram compares those ancient worlds to our current ones. While Theia dominated the orbit, its companion was still significant, roughly twice the size of our modern Moon. Because these 2 worlds were so massive and positioned so close together, their gravity created an increasingly intense pull. This physical attraction acted like a tightening coil, steadily shrinking the distance between them with every passing orbit. This movement was a mathematical certainty. Their shared gravity made a collision inevitable, locking both worlds into a multi-million-year death spiral. This collision would provide the specific physical materials and kinetic force needed to build the multi-planet system we inhabit today. When the 2 planets struck, the impact generated enough energy to instantly fracture their solid crusts. Both worlds shattered, releasing a massive cloud of debris. The impact was so thorough that the original planetary structures were lost, replaced by an expanding field of molten rock and shrapnel. This diagram tracks the mass of the larger planet, Theia. As the debris cloud cooled, its core volume divided into 2 distinct spheres. The first half settled into a stable orbit closer to the Sun, cooling to become the Earth. The remaining half of the parent planet was thrown further out, stabilizing into the orbit we now identify as Mars. Because Earth and Mars both originate from the same fractured volume of Theia, they are effectively cosmic twins, sharing the same physical lineage. While Theia formed the major planets, the smaller companion world also fractured into 2 large pieces during the crash. The force of the impact hurled the first half of this smaller planet inward toward the intense gravity of the Sun. This fragment became Mercury. Because it only achieved its planetary form after the collision, long after the initial solar system began, it holds the title of the youngest planet in our neighborhood. The second half of that smaller planet took a different path, drifting into the gravitational reach of the newly formed Earth. As the diagram shows, Earth's gravity captured this incoming mass, locking it into the permanent circular orbit of our Moon. Not every fragment formed a massive body. The collision left behind millions of smaller, irregular pieces of rock scattered throughout the impact zone. Many of these jagged fragments were caught by the gravity of Mars, where they remain today as the planet's small, misshapen moons. This single event organized the solar system into 3 distinct tiers: the major twin planets, the captured inner bodies, and the remaining planetary shrapnel. These new worlds didn't start as the smooth spheres we see today. They were initially jagged and asymmetrical, with massive lopsided regions created by the uneven cooling of the impact debris. 2 primary forces began to act on these lopsided masses: the inward pull of gravity and the centrifugal force of the planet's own rotation. In this diagram, you can see how gravity and rotation create a constant grinding force. They are physically pushing the uneven surface plates toward the center, attempting to reach a more stable spherical shape. This reshaping is a slow geological process that has lasted billions of years, and it hasn't finished yet. This ongoing struggle for balance explains why we still detect seismic activity today. As gravity pulls on those ancient, uneven sections of the planet, the crust must crack and shift to accommodate the new, more rounded form. Every earthquake, moonquake, and Marsquake we record is the physical result of our world still gradually settling into their final, rounded shapes billions of years after their violent birth.